What we are going to talk about today for about an hour or so is the XP Builder software. We're just going to be going through like the basics. We could spend 3 or 4 days going through all the ins and outs of the software and all the neat things you could do with the HMIs, but this is kind of just meant to be a little bit of a foundation, enough to be dangerous with. I see we have some reps on here, some distributors, and some guys that are probably even going to be doing some HMI programs. So we've got a nice mixed bag of, different, skill sets and levels that, people are going to require, to help sell the HMI. First thing I'll mention is the software is called XP Builder. And there's a few different spots that you would Yep, that's correct, Andy. You're just going to see the browser for now. What you're going to do is find the software first off. So there's a few different spots. So we're trying to get up on our website. We were having an issue. So hopefully it'll be up by this afternoon. But if you went to the LS Electric America website, you click downloads, you click software. XP Builder is the first one there. But you'll notice the manual's there, but the software is not there. So we're working on getting that fixed probably later today. Other ways you could get the software is there's always the global site. You just go to Support and Services, Download Center, filter down to Automation, HMI, and then you could just click the software box, and then it'll be one of the first things that comes up. Here we go, XP Builder 3.10. So 3.10 is the latest version for now. So you get from there, and then also you guys could always request it from us. Shoot us an email at the tech support inbox, or shoot John, Jason, or I a direct email. We could share a Google Drive link with you as well. So one thing to note about the XP Builder software is it's free. There's no cost or no license or anything associated with it. So it should be pretty easy to obtain and test out and stuff. So a couple other softwares that are out there to take note of are XP Manager. So what XP Manager is used for is that's for installing the driver on the HMI. So you could remotely log in and remotely monitor the HMI. So you could do that from your PC or your phone. So XP Manager is how you would set up that. And we also have XP Remote. XP Remote is the software for actually remoting in. If you wanted to connect your computer remotely to an HMI off-site, you could use that. And then there's also another app that you could download on your phone called VNC Viewer, and you could use that to connect to an HMI, from your mobile phone. So a few different options there. So we're not going to talk about all that setup and stuff. That'd probably be another training, but just be aware there's, a few different softwares, for doing various things with the HMI. So let's say we downloaded the XP Builder and we started up. So I'm going to open up a new project here. Give that a second to load up. All right. So what I'm going to do for time's sake and for troubleshooting, I don't want to mess up a program and then troubleshoot it for an hour on a webinar. So what I'm going to do is I'm going to create a project, and I'm going to show you guys just some basic things we could add on, to our screens and how we could change screens and stuff like that. And then I'm going to open up an existing project just for demonstration purposes and kind of show you how that works as well. So I think that would probably be the best use of all of our time. So you could open a project if you have an existing project. I'll do that next. But first off, I'm going to create a new project. So create a project. And the first thing you'll get is what series are you using? So as you guys know, or maybe you don't know, we did have a HMI webinar. Oh, it's probably already 2 months ago, if not more. We have a few different series. The ones that we sell and support in the US are the EXP and the IXP2. These other ones, these IXP and XP, those are older ones. And then this IPC is kind of like a specialty HMI. So what I have next to me, if you guys could see my camera where it's pointing at the HMI, that's an EXP. So I'm going to select EXP series. And then you have to select what model. So the EXP20 is a 4.3 inch. Then the other ones we stock besides the 4.3 inch in the US are the 7-inch guys and then the 10-inch. So what I have is a EXP40 TTA. That's a 7-inch screen. I'm going to click that. And you could just find that on the back of the HMI. So there's going to be a nameplate there. Then the next thing you have to do is you have to select your controller. So these controllers, these are all the drivers. So some of you guys are, shooting us emails and giving us calls about what we could connect to. So some of the more important, or I wouldn't say more important, some of the more common ones we get requested for is going to be, Allen Bradley, but you look under A and you don't see Allen Bradley. That's because they put it under Rockwell. So there's Rockwell Automation. They got the Control Logics, the Compact Logics, the SLC 500, the older DF1s. So these are all of our Rockwell drivers. We have the standard Schneider Electric Modbus driver. This is probably the second most common driver we use, which is just basic Modbus RTU. You'd probably select RTU on this one. And then we have a bunch of LS drivers. So if I scroll on here, LSIS. A lot of these are PLCs. So the GM CPUs, the Master K, which is like an older series of PLCs, the XGBs, which some of you guys may be working with now. We have the Ethernet modules, even the servos and the servo drives. So what I'm going to do is I'm going to set this up for the inverter Modbus. We got to use this one here. So, and that's because my demonstration or sample program here, all I'm doing is I'm connecting an HMI straight to a G100 drive. So technically the G100 is the controller. After you select your driver, then you have these communication settings here, and you could always change this later. Oops, I think I might have hit the wrong button. Here we go. Here we go. So this takes you to our properties for our controller protocol. So our protocol is RS45. The serial port we're going to be using is COM3, so that's the port on the back of the HMI that we're going to be physically connecting to. And then these detail settings. Here's like your baud rate, your data bits, your parity, your stop bits. So pretty much all of this is going to have to match up with the drive that you're going to be connecting to. So we're going to set this. I think I have mine set as high as it could go, which is like 115K, and then everything else I leave pretty much the standard. Okay. So you hit OK. And then you could always add in more controllers. So we do have multiple ports. We have COM3. I think we have a COM2 on the back. We have an Ethernet port, and you could run more than one protocol at the same time. So you could always add more controllers. And one of the nice thing about all these controllers and drivers is there's this refer to manual here. So if we click this, there will be an 11-page manual for whatever controller you're set up for, whatever protocol, whatever driver. So if I scroll down here, it says, hey, these are good for connecting to all these drives. And this list is a little bit old, but all the drives use the same communication protocols and the same common registers, so it'll work with whatever drive we're connecting to. Here's a wiring diagram for 485. Wiring diagram for 485 over the EXP. So this is actually what we're this is for COM1. We're using COM3. So this is the wiring diagram right here for COM3 for an EXP40. And then you'll notice it's a little bit different on the EXP20. So for those of you guys that have HMI samples, the EXP20 is the 4.3-inch one. And that one only has a D-sub connector on it, those 9-pin guys. So you'd have to figure out what the pin out is, and this is the pin out. So that's just referenced, right in these manuals. And I think there's stuff talking about messaging format and stuff like that in here eventually. So yeah, communication settings. Yeah, here's all how you set it up with the parameters. Okay. So let's just say to show you guys something I think it's pretty neat, is you could select a Rockwell, let's do a Control Logics PLC, and then you could click the manual. And then now we have a different manual. We have a 14-page manual. Talks about the different PLCs that are compatible here, how you would set it up, how you would create the file and the controller tags, which is another common question we get is how to do the tags. communication setup. So, I mean, step by step, how you're going to plug in your IP address and test your connection and everything. Step by step, how to connect up to each controller. We also have like some Siemens S7 controllers and drivers and stuff. So I'm just going to change this back to the LS one we were using. We use Modbus. I don't know if there's much of a difference. See, that's how you check the manual. It should be the same. Okay. And then I might need to reset my setting. If your baud rate doesn't match and your addressing and data bits and everything doesn't match, then you're going to get a timeout. And I'll give you guys an example of that later. So this is just a warning saying that we changed the controller type. So it's going to readdress everything. Just hit OK. Okay. So if you ever need to change that, you could always go back to this project tree on the left. So all of your items that you're going to be playing around with for the most part are on the left and the right. So on the right, we have our toolbox. That's where you could toss in shapes and switches and displays and stuff like that. And then everything on your left is your project tree and then your different screens. So if I wanted to say, oh, I need to change my baud rate back to 9600, you don't need to make a whole new project. You just click the panel settings. And then there's the project summary. You could change the project name. Here's the EXP series we're connected to. You could click that detail setting and you could change that to whatever you need. There's other things in here like the screen settings. You could like do different addressing for different windows to pop up. We don't have an HDMI option on the EXP, but this would be available if you're connecting to an IXP2, which is kind of the higher level HMI. We have different security keys in here. There's 9 different levels of security you could plug in. We're not going to talk too much about that because that's a whole nother topic, but I'll show you where you guys can find out information on that towards the end. There's different languages you could select from. Let's see, this is just kind of pointing to the different memory on the HMI you could store things in. Auxiliary settings. I've never ran into this. This is probably for like peripheral devices and stuff. So plenty of things to play around with there. But now that we got our project started and we have our communications all set up, this right here, this black screen right here is our base screen. And I can tell it's our base screen because if I look on the left side right here, it's highlighted on base screen. Okay. So this is kind of like your open canvas. This is what you're going to see on your HMI once you dump the program into it. So let's go ahead and add some stuff. So first thing I usually like to do is change the color. I mean, you could leave it black, but you could just right click the screen, go to screen property, background. I'm going to say use a background color. I'm going to change it to white. Then hit OK. And now it's like white, eggshell almost. So very easy to change stuff like that. So now let's add in a few switches. So let's do this first off. So we have one screen, and a lot of times you're gonna have more than one screen. You could have one screen, but if we want to add a new screen, we could insert another screen, insert a base screen. Just hit that little plus, and it should pop up with another screen. There we go. Okay, so now I got a base screen. Base screen 1, base screen 2. If we want to change the screen properties, we could choose the background color, set it to the same as the other guy. All right. Then you could also copy and paste screens too. So you could select it. I'm going to do a Control C, and then a Control V, and it's going to say paste the base screen. And then it's going to say, where do you want it in as far as position? Do you want it to be 0, 1, 2, or 3? So I'm going to put it as 3. So now it's going to be in a consecutive order. Okay. So those are 3 base screens that we have right now. Now the next thing you'd probably want is some kind of way to switch from one screen to another. Okay. So we do have this simulation tool up here, and I usually describe this as it looks like a YouTube kind of icon. So if you see where my mouse is on the top left, the red little play symbol here, this is a simulation tool. So if I click that, here's my screen. Nothing there, just a white canvas. But I'm on screen 1 right now. So the next thing I'd need to figure out is how to get to screen 2 and to screen 3. So this simulator is nice because you don't need to connect to an HMI. You're just simulating on the PC, and you can kind of see how your layout's going to look without dumping in a program every 10 seconds, for minor changes. So how you're going to make a screen switch is you're going to go over to the toolbox. So on the right side here, and this is customizable. You could put the toolbox on the left. You could put it on the top. You can make it wherever you want. But the toolbox is where you're going to have stuff like lines. So you could grab a line. You can put a line on the screen. Let's make like a black line right here. Okay, very simple, just like Microsoft Paint almost, right? You're just dragging stuff around. To make a screen switch, you have to use a special switch. So that's under Objects. So you click it, and then what you do is you kind of drag where you want the shape to be. Okay? And there's a ton of special switches here. There's alarm viewers, which is, again, another topic. Alarm and logging, trending. You could do multimedia and PDF viewers. That is for the IXP2. I don't think you could do it on the, yeah, it doesn't even give me the option here. So you could have a video playing on your HMI for the IXP2. You could have PDFs, that open and close. Like you could toss a manual in your HMI, just make it a little bit more user friendly for the OEM or the end user. So what we want is let's see, a special switch. Yeah, right here. Okay. Yeah. So sorry about that. I lost track of what I was doing. So, all right, so now we have a switch that's going to show up like right here, and we need to tell it what it's going to do. So you click the change screen button. So we're going to switch from a base screen to a base screen. You could have it go to previous screen, or you could have it go up to the next screen. So right now we're on base screen 1. So I'm going to have it go up to screen 2. Okay. Hit OK. And now this will be a button that goes to screen 2. So just to make some sense out of this, because all the screens look the same, right? I'm going to call this, sorry, I was working fast there. I just grabbed this text box and then threw it over on the left here. So I'm going to say screen 1. Let's change the color to something other than white, and let's make it a little bigger. Okay, so screen 1. And I could copy this, Control C, and then I'm going to go into screen 2 now. Here we go. Actually, I have this on the wrong screen. So what I'm going to do is I'm going to copy this, put this on screen 1, and then I'm going to go to screen 2. I'm going to delete that. Oops. Oops, I lost my screen. So let's do another screen here. Insert base screen. Here we go. I'm going to change my color real quick. Screen properties, background color. Here we go. Okay. So I'm going to change this to screen 2, and this will just make more sense once I'm looking at it, so I'm not just looking at a plain white screen. And then now I'm going to go to my third screen, and I'm going to paste it again. And I'm going to change this to screen 3. So I also pasted that button, you guys may have noticed. So actually we're on base screen 3 right now, and if I click the button, it's actually going to move to screen 2. So that would be a little bit weird, right? So I'm going to change it to go back to screen 1, so it cycles around, because we're at the end of the list. Okay, and then now I'm going to go to my second screen. This one's moving to itself, screen 2, and this is just because I copy and pasted it, but I'm going to make 2 go to 3. And then if I double check 1, this one should be going to 2, right? Yeah, okay. So this is like kind of like a forward button, right? So you could actually double click it, and you could click the text. You could use a caption, and then let's just say we'll call this next screen. And then this is for the on display. For the off display, there's nothing. There's this little shortcut button here, and this will copy it from the on to the off. So now it'll say next screen on both displays, whether it's on or off. Okay, I'm going to delete this line. it doesn't look good. And then you could do the same on here. You could just change it to text, use caption, next screen. Copy it on both the on and off. And then we'll do it on this last one here. And then we'll test it out real quick, just to make sure that our work is doing something here. So use caption, on off. You could always change the font and the color and stuff like that. There's spacing and alignment and all kinds of things you could play with to fine tune it. And I'm also using a very basic switch here. This is just the default. You could double click it. You could click display, and then you could click library, and then there's a bunch of different switches. You could filter down by color. You could filter down by lamp or switch type. You could search by raster images or vector images. You could search by rectangle, round. I mean, there's thousands of buttons, and I'm filtering everything. So I got like toggle switches, like pictures of pipes and tanks and everything. So there's plenty of images available in the library. Let's just hit OK on this one. Okay, so now it should loop all the way around in one direction. So we could test it out in the simulator. Again, the simulator is just a faster way to see how things work instead of connecting to an HMI and writing it every time. So screen 1, screen 2, screen 3. And we still have that line there, so if that's something that bothers you, you could just click it. We also have the tabbed displays up here, so screen 2, you can see where my mouse is, that's up top here. Base screen 1, base screen 3, base screen 2. You should be able to drag them around if you want them to be in like a sequential order. So that was just a basic screen switch, and what we used for that is we used a multi-action switch, as it tells us at the top right here. Okay, so we're not really doing anything with the VFD or the controller that we're going to be connecting to. We're just kind of making some easy to navigate, pages. Okay, so let's see. We got that. We changed our background color. You guys saw how we added text. You could also add like, shapes and images and stuff like that. So that's all under this kind of figure section. So you could add an image. There's all these preset images that are just in the library. So like if you don't like, that button there, you could actually use like an arrow key as a button to go to the next screen. It might look a little cleaner instead of just this, kind of older looking button here. You could also do user stuff. So right now there's nothing here. So you actually need to make a category. So let's call this HMI G100, test. So now it's going to make a folder. And then within that folder, you could right click and you could insert an image. Okay. So you could go to like your pictures and then you could find, an image like this, let's say. Now we have an image here that we could, and this is a little preview of the image, and you could add it into there. Then you just, same thing, you just drag and drop it onto your screen. All right, so the next thing I'm going to do is show you guys how we are going to add like some switches and stuff and, map it to the G100, okay? So a few things about that is you're going to have some knowledge of what you're doing with the Modbus to, get it working. So what I would recommend is using the manual for whatever drive. In this example, we're going to be connecting to a drive. So we're going to be connecting to a G100. So, of course, this manual is available to all you guys. It's on our website. All over the place. So this is like, I think, chapter 6 or 7. Yeah, 7. Here we go. So 7 is RS-45. That's what we're using, right? Modbus. Okay. So you find all your specs right here. Hey, we can connect up to 16 drives. It's a half duplex system. Modbus RTU is what we're using. And hopefully that sounds familiar. Even if you don't know much about communications, that's what we set up our HMI program to run off of, right? Modbus RTU. So here's the wiring diagram. So S plus and S minus. The G100 has 2 different points. So does the M100. You could either connect to the hardwired terminal strip, S plus and S minus, or you could plug in an RJ45 connection, which is kind of nice. Okay, this just shows, you know, the topology for a line. And what we're looking for is stuff like this. These are the parameters that you're going to want to make sure matches up with your HMI program. So you're going to have your address set to 1. So you want your HMI to know that we're going to be looking at address number 1. And that's also important for mapping the switches, which we'll see in a second. Communication speed, it defaults to 9600. We're going to have to change that to the 115 kilobits per second because we want that to match up with the HMI program. You could scale everything down to 9600. I just set it up as fast as possible, then it makes the HMI a little bit more responsive. If you have a bunch of drives on the network, maybe you'd want to slow it down a little bit. Here's that data bit 8, parity none, stop bit 1. That's what that breakdown is right here. And then there's a little bit more description of what all the numbers would be on the keypad. Okay. And then most importantly, what we care about is if we go in a few more pages, this is how everything's broken down. There's a register table. The drive U9 stuff they tossed in. Oh, here we go. So this is the common area parameters, which are really just registers. So these registers here are the same registers on all the LS drives. So the nice thing is that if you can figure out how to communicate to a G100, which is what we're going to be doing here, you could take all these same registers and connect up to an S100, an IS7, an H100, what have you, and it's going to work pretty much the same way, okay? The scaling is going to be the same, the addresses are going to be the same, and everything. So that's kind of a nice thing. It's all common, so that's why they say common area. All right, so let's add some switches into our HMI program. So the first thing I'm going to add is a run button, okay? So these are actually going to be, you'll notice there's a few different switches. There's bit switches, there's word switches, there's the change screen switch. Oh, there it is right there. Last time I was using it as a special switch, so it was not that easy to find. Multi-switches, and then there's bit lamps, which are all like monitoring devices. Okay, but these bit switches and word switches are you're actually writing to these registers and you're turning things on, you're turning things off, you're changing parameters and whatever. So what we're going to use is we're going to use a word switch because if we go here and we look at our operation command, so if we want to run the drive and stop the drive, so we have a forward operation, reverse operation, a stop operation. This is a 16-bit word. Okay, it's a bit, but each bit makes up a word. Okay, so we're going to use a word switch. So I'm going to click word switch, and then I'm just going to drag that onto the screen. And it made a little switch there, but now we need to actually map it. So that's what this device area is right here. So if you know how to do the formatting, you could just plug it in. Otherwise, you could click this little calculator, and it says that we're going to connect up to the LS inverter, okay? And it defaults to this iDevice, okay? That's the only option we have, which is just like LS inverter device. And then the next thing you got to do is you got to plug in what the address is, okay? So if we look back at the table, let me change this here so you guys can see a little bit better. This is hexadecimal address 6 is all of your operation stuff, okay? So we're going to just change that last bit or last digit to a 6, okay? And then hit OK. Now, what we're doing is we're actually going to be writing a hexadecimal value to this address. So if we write a 1, what that's going to do is you actually have to break down, I mean, without some of this stuff I know you guys might not care about, but all these bits are like, you can kind of think of them as like a binary sequence. So there's 0, and then there's 1. And then if there's 1, 1, that means you have bit 1 and bit 0 on, which pretty much means you're going to stop because you're trying to run forward, but you have your stop bit enabled. So right now with it set to 1, that's actually like a stop button, okay? And if we want a forward button, we want to turn on bit 1. So bit 1 would be a 1, 0, okay? So that's actually going to be a 2. So when you convert 1, 0 in binary to decimal, it's going to be a 2. So we're going to change this to write a 2. Okay. Now let's also change the image just for practice. Let's find a nice button here. So these are all lamps. I'm going to change it to a switch. Let's make it a green switch. Sometimes I feel like I spend so much time just trying to find the perfect switch. Here's a nice button. So this will be our start button. Okay, and then you'll notice that like it kind of uses a reverse image. I don't like that, so I'm going to uncheck that. And then I'm going to do a on-off copy. So then the on and the off are the same, because this is just going to be a momentary push button. Okay. And then we can hit OK. And then this is our run button, but nobody knows it's a run button or a start button until we add something in there like forward run. Okay, oops. And then the color's not right, so I'm going to make it black, and I'm going to make it a little bit bigger. There we go, forward run. So now let's say we want to do a stop button, because we don't want it to run infinitely. I'm just going to copy this. Oops, you don't want to copy too much. Control C, Control V. Then all we got to do now is we have to change the addressing. Move it up a little bit. There is an align tool somewhere up here. You want to use that. I'm going to change this to a just like a stop button. Okay. And then if we want to stop, all we have to do, if we look here, is we just have to turn on bit 0. So we have to convert that over to a binary, and that's just going to be a 1, because it's the first bit. So we could change this to write a 1, and it's green. It's a green button, so I'm going to change it to a red button. So we could just change this to a red filter, change that. Oh, and then we also have this, so you could change your on image as well to a red button. Okay. Okay. And so now we have a forward run, and then we have a stop. And these are mapped to hexadecimal address 6. Hexadecimal address 6. Okay. You could also, let's say we have 10 different G100s all on the same network. We could do that as well. You could, so if you wanted to like clean up your program, you know, you could say, let's make a little box here, add in your text. Let's just say this is VFD number 1. Okay. It keeps defaulting to that different color. So let's make it black. Let's make it a little bigger. You can make it bold. There we go. So VFD1 controls could be right here. Then you could copy all of this. Move this up a little bit. Oop, too much. There we go. Control C, Control V. And have to get that screen in there. There you go. All right. So you could like move this down. And so once you get like your basic program working, you could make like a VFD2 right here. But right now these buttons are all the same, right? They're all going to VFD1. So there's a little trick here. If you're using more than one VFD or more than one PLC or more than one device, whatever you're connecting to, you could change this to write to a certain address. So I'm going to write to address 2. So you just put a hashtag or pound symbol 2 colon. Okay. Same thing for the stop. Pound symbol 2 colon. And now you're going to want to do the same for this, because we added 2 devices. If you don't have that specific address in front of here, it's just going to write globally to everything on the network. So you're going to want to set this to a 1. So that way you're only controlling VFD1 and you're only controlling VFD2 accordingly. Whoops, now I said 2, but I put 2, but it should be 1. Okay. So now we have a couple controls here. I'm going to add a couple more things before we switch over to our live program here. So the next thing I want to add is going to be a numeric input. So most commonly, the only two things people are controlling on a drive is, starting, stopping, and then controlling their speed, right? That's one of the whole purposes of a drive, is having the speed control. So for that, all we need to do is scroll down. There's a lot more objects than what we're talking about here. I mean, quite a bit. So what we're going to do is we're going to use a numeric input. So if we click numeric input, toss it onto our screen here, it's going to ask for an address. So I want to write a speed reference, okay? So to figure that out, I go to the G100 manual, target frequency, hexadecimal address 5. Okay, and so let's do it for VFD1. So you could click this. This will do the formatting for you. You just plug it in at 5, hit OK. And then if we want to write it to only drive number 1, you're going to put the 1 in front of there. Now here you got to be careful because there's signed decimal, unsigned decimal, all these different things. Pretty much I just leave it at the unsigned decimal. And then the thing that's going to matter is the number of display units and then the number of decimals. So how you would find that out is you click this again, and you can see that the scale is 1.01. So there's 2 decimals, and it's actually going to be a scale of 4 because your maximum speed is going to be 60 hertz, so 0.0. Enable formatting, you could enable scaling, plenty of different things you could do there to customize it and make it look just how you want it. But let's just kind of keep it basic now. So now I got to set this back to 2 decimals. And then you could change your display. It defaults to this very basic image. So you could always change it to, let's see, maybe some other kind of image that's not a specific color. This one looks kind of like some kind of screen. We could hit OK. Here we go. And you could always go in there and you could change the text. You could change the alignment to be in the center and make it bigger. You could change the color of it, but I'm just going to keep it pretty basic. So this is actually for VFD1. I'm just going to put that right there. You could add another thing. You could add more text. I'm just going to copy the same text from this. And I'm just going to call this, so this is my input speed. So let's call it input frequency. All right, so this one, again, it's a numeric input, so it's going to change the frequency. The last thing I'll show you here is, let's move this up out of the way real quick. Let's say we want to monitor that frequency, see what the output speed is, or see what the output voltage is, okay? So for that, we're going to use a numeric display is one thing you could use, or you could use a meter graph. So a meter graph, just to show you what it looks like. Let's just hit OK. Let's change the display to something like a half circle. Yeah. So you could make a little meter graph here that's going to go up and down with, motor voltage, output frequency, or whatever. All you need to do is you just map it. So same thing. Let's say we wanted to look at output frequency. Let's see, we should have output frequency is address A, hexadecimal. So A, okay. And then if you wanted to assign it to, drive number 1, that's all you would do. And then you could toss that up there. Then you could add a text on there. You could do whatever you want. Okay. All right. So that's just how you do some basic drag and drop and, some stuff like that. So what I'm going to do now is I'm going to open up my actual program here. So I guess the key thing to keep in mind is you're always going to have to reference to the manual for whatever device you're connecting to. So let's close out some of this stuff. So here's my program. Okay. So it's very similar to what we already did. Okay. So this program is available to you guys. I think some of you guys have already seen this program and used this program. It's very simple. It's just the LS-HMI connected to G100 drive, 2 wires, S plus and S minus. Set up these parameters on your drive, and then everything should work. Okay. And so as it says here, this is a sample program that demonstrates how an LS-HMI can read and write data over Modbus to a G100. So set up the wiring and parameters below, and then once you're done with that, you can go to the next screen. Okay. So if I go to my second screen here, you can see my buttons are writing to VFD address 1, register number 6. We're writing a 2, same as before. Here's our speed reference, address 5. So hopefully this matches up with what we did before. Output frequency is address A as in alpha. And all of these registers, so let's check out this one. Output voltage is B as in Baker. So if we check our G100 manual, B as in Baker, that's output voltage. So everything's lining up. So everything should work in this program. One thing I didn't show you guys for sake of time is these bit lamps here. So this fault, this stop, and this run LED, these are all bit lamps. So you can see we're reading address E as in echo, bit number 3, and that's a fault. So if we go into here and we find E as in echo, yep, these are all operation statuses. B is bit 3, that's a fault trip. That matches up with this. We have a stop, which is going to be the same thing, but a different bit 0. And then I think running is bit 1. Yeah, E1 is bit 1. So we should see these lights come on and off when we're stopping and running and doing different things. And then the last screen we have here, nothing's going to show up here now because these are all referring to text tables. So for example, these are just easy numeric inputs right here, this accel and the decel time. So you could change your acceleration and deceleration times. So those are actual parameters we're changing in the drive. These are pretty much all monitors here that we're reading the output voltage, we're reading the output frequency, and then we just copy and pasted the run and stop buttons onto the second screen. So you could do some different things. Same thing with these LEDs. These are the same LEDs that were on the other page. Same mapping and everything. What these buttons you could see is they're multi-action switches. So it's doing a word set. It's writing to it's writing the hexadecimal address 340, and so that's actually a parameter associated to parameter AD64. So this is the cooling fan control. Okay, and then this parameter is referencing, or these multi-action switches are referencing to text tables, which are on the left right here. For during run simulator, it should pop up. Then it won't show up blank. So we have the screen buttons on the top here, next screen. I actually have a button for a previous screen too, a little bit more user-friendly. And here you guys could see the buttons. This is just right from the text table, right? 0 is during run, and when we click this, we're not just changing something on a display, we're actually writing to this parameter on the drive to turn the fan on, to turn it off until it gets hot, or to turn it on only when we're running. Same thing for torque boost and the stopping modes. These are just things to demonstrate, to customers, so when you actually hit a button, it changes something in the drive. So let me show you guys how the program works. So if I wanted to write this, let's say I made the program, you make your project, you save your project, and then you want to dump it into the drive. Easy to do, you just hit the download button. That's this little blue arrow is the download. The upload is to pull it out of the HMI. So I'm connected over USB. I recommend doing USB whenever possible because it's nice and easy, plug and play. Other options you have are RS-232. This is what you have to do with the little EXP20. Those are the 4.3-inch screens because they don't have USB on the front. Or you could do Ethernet, which that works out pretty well, but it's always tricky getting your computer on the same Ethernet network and worrying about firewalls and ports and fun stuff like that. So again, I recommend USB. Another thing you could do is, let's say we take this project file, we could save it onto a thumb drive, and then we could plug that thumb drive into the HMI and then just load it in. That's the easiest way to do it with the smaller screens because they don't have a USB interface on the front. You just use the one on the back. And we do have steps that shows you how to do that. So you would just click this, and then you would download the program. And then it'll go into your HMI. So my program is already downloaded here. So I'm not going to download it again. So let me, I'm going to flip my screen off here. And then you should see... So now the video should be bigger, hopefully. If not, maybe enlarge my screen here, my little video, just so you can kind of see what's going on. So I have this actually connected to a G100 to the left here. So right now you can see our bit right here says stopped, and the VFD is stopped. And we're going to hit run. The motor starts spinning. So this is just a animation that I have mapped to the run bit. My run light came on. I could stop it. It's going to ramp down, and then my stop light's going to come on. I'm going to run it again. I also have a trip set here. So this is actually a virtual digital input that we could write over Modbus. So I could trip out the drive, and as soon as I hit trip, the fault light should come on. When fault light came on, stop light came on. We could reset the trip. We could run it again. Our speed reference is 15. Our output frequency is 15. So we could change our, let's go up to 40 hertz, hit enter. It starts accelerating faster. We could see our output voltage, our DC bus voltage. And I'm going to go to the next screen now. You could change your accel and decel time on the fly. We could change it to like a 50-second accel. Let's do 3-second decel. So now when I stop, should ramp down pretty quick, and then it should take a while to ramp up because I have a 50-second accel. So you guys can see that number slowly creeping up. Hopefully it's big enough to see. Right now the fan is set for temperature control, but if I turn it to on, you guys should hear a somewhat loud fan kick on. So I'm going to turn that off so you can still hear me. Now it's not going to come on until we get to a higher temperature. You can see your output voltage here. So this motor is very small, so the output voltage is pretty low. We're still ramping up. We could change our stop mode. Right now we're decelerating to a stop. We could stop this. We could do like a coast to stop. So that'll just coast to stop. There's not much of an inertia on this anyways, so it's not going to do much. And if we hit our next screen, it should loop around. Back to our first screen. I might need to check that button. Might not be mapped right. Yeah, everything else is working. Yep, so I think this button might need to be remapped. So you could always go back. Let me share my screen again and see why that button is not working right. So this is, yeah, it's set to move to screen 4, but there is no screen 4. So if I wanted to change that, I could go back to screen 1. There's a little bit of troubleshooting. We could dump the program back in here. And then, so now if you guys look at my camera here, you could see the progress bar saying that it's downloading the project data. If you saw the LS logo, that's actually a custom thing. You could add any image you want as a splash screen. So now we go to the second screen, we go to the third screen. There we go. Now we go back to the first screen. So we fixed that. So the last thing I'll show you real quick, just as a little trick to know, is let's say we get a PLC timeout. So what I'm going to do is I'm going to shut my drive off. So if the drive's off, obviously we're going to lose communication because we can't communicate to a drive with no power. So in a few seconds, we should see a PLC timeout come up on the top. We'll give that just a moment. And then everything should be blank. Yeah, it's already acting slow. So nothing's popping up here. All the bit lamps are gone. All the displays are blank. And it should come up with a PLC timeout because there's nothing there. There we go, PLC timeout. So the PLC is the drive. It's saying there's nothing there. So it could be something wrong with the setting, the wiring. In this case, the drive's off. You could also go and you could check out some settings in the HMI. So what you do is you press and hold in like a blank spot. You can't click here because it's going to come up with like a little input. So click on a blank spot, hold it for a few seconds. And if you look on the bottom, you could click this little, like a little picture of a computer or something. It's going to go into your settings. So settings, we have all of our Ethernet settings, we have our touchscreen settings, we have our buzzer settings. So that's just the little beep that you guys are hearing. XP remote for remote login. PLC information is LS inverter. You could click settings. You could see, here's our baud rate, here's our communication port, here's our data bits, our parity, our stop bits. So you could change all this right here on the fly instead of loading it up on the HMI program, XP Builder. So that's something you could utilize it as. There's the, let's see, I think it's show info. Yeah, so PLC, and everything is like timing out right now because we're not connected to anything. And controller station is 1, so that matches up with our drive. If that was incorrect, that would be another thing that would cause issues. So, yeah, so that's kind of like a basic crash course on the settings and stuff. You could hit start, and then that's going to start up your program again. So now we're back to where we were. We're going to get a timeout. Let me turn the VFD back on. You'll notice your program will run slow because it's trying to communicate, so the buttons will be a little bit sluggish, but now everything's working again. Toss in 10 hertz. Now everything's running. All right, so again, that program is available to you guys. If you don't have it yet, feel free to shoot me an email, and we can send it to you, help you guys get it going. Once you get past the hurdle of getting your computer connected to the software, and getting the program in there, it should be pretty easy and a good demonstration tool.